Hello guys, welcome back, and I want to greet everyone. So hey everyone, welcome back to Expert Panda, where we break down coding problems and the system design concepts like a pro. Okay, so today we are going to solve a very interesting binary tree problem, and that is nothing but Leetcode problem 1123, and we have to find the lowest common ancestor of deepest leaves, right? So let's dive in that. Uh, and so I'll tell we will do some hands-on there coding problems, and we'll try to implement in front of you, so you can think as much as we'll talk middle of the coding, right? So uh, what we have given here, right? So first of all, we have given the root of binary tree, and you need to return the lowest common ancestor of its deepest leaves, right? So as you can see here, right? So this is the problem we have given. This is the problem we have given, right? And in this problem, this is the example we have given, right? And so you need to return the lowest common ancestor of its deepest leaves. So in this case, as you can see in the graph, right, we have 2 and 2 having 7 and 4, right? So 7 and 4 are the leaves having the depth root, and it doesn't have any further children, right? So a leaf is a node with no children, and the depth will become from it will start from 0, right? So you can say that, right? So the lowest common ancestor is the deepest node. As you can see, 7 and 4 is here, right? And that has all the deepest leaves in the subtree. As you can see here, right? So example is saying this is the thing we have given, and if we talk about the deepest leaves, so 2, 7 and 4 become the deepest leaves here and the ancestor. So we have to return this tree for as a deepest leaves, right? So like that we have to think what we are doing here, right? And then we have to go one by one to understand this, right? Let's come to the point where we have to think little better, right? So as you can see here, right, give me a second. As you can see here, right, so this part will become the answer of our problem, right? And because this is the deepest leaves, right? Let's suppose we have some other problem, right? I will write here. Let's suppose we have 1 as a node, then we have 2 node, then we have let's suppose we'll make one 3 node, right? And then we'll make another node, let's suppose 4, right? So if this is the tree we have, right, I'm going to make you more understand with the example, so you will understand this, right? So in this tree, the deepest node leaf is what? 4, right? As you can see here, right? So this is the deepest node 4 we have here, and so the LCA is 4, right? So it is saying LCA, least common ancestor. I will talk more in the problem, right? LCA. So the lowest common ancestor of this tree is nothing but 4, right? So in this tree, if you'll talk about the deepest node, the deepest leaf node is 4, right? But let's suppose uh, we have something that is having same two you can say nodes are having the same size, right? So in this case, let's suppose give me one second, I'll take another color. Okay, so in this case, let's suppose there is one more, right? Let's suppose 5 is added here. Okay, so now you can think the deepest leaves are 4 and 5. This is also deepest and this is also deepest, right? So the deepest leaves are 4 and 5, and the lowest node that contains both is 1, right? So LCA is become what? 1, right? That is why we can say LCA is nothing but 1 here. So you have to understand the code will say that, right? What we have to do. So if you read the statement again, it is saying the given the root of binary tree, and it will return the we have to return the LCA of its deepest leaves, right? And recall that the node of a binary tree is a leaf if and only if it has no children. That is called leaf node. That's the last one. And the deepest of the root of the tree is 0 if the depth is d. So the depth of each children become what? Of its children is d plus 1. We have to code on 1 plus 1. So if it is d, let's suppose if it is d, it will become what? D plus 1, d plus 1, right? Like that. If this is d, d plus 1, we will do again d plus 1 plus 1, like that, right? It will keep improving. Or you can say d plus 2, we can say, like that, we can say that. Okay, so in this case we have seen, right? So if you see the red color tree, right, so only 4 is a 4 will become the LCA, right? But if you'll talk about the complete, this one red and green, so there is there is two node that is having the deepest leaves as a 4 and 5, right? And so the lowest node that contains both is what? 1, right? It contains both 4 contains and 5 contains, and so the LCA is nothing but node 1. Okay, because it contains both, right? So that we have to understand here. Okay guys, okay, so now we will understand the coding part, right? So let me zoom it out, right? And better, let me expand this, okay? So we have already given this prerequisites class, right? That is tree node, and we will implement here, right? So let me go here and I can put it here. Okay, so this is the function we have given already. So LCA deepest leaves, and we have given as an argument tree node we have given, right? So what we have to do here, first of all we have to find the max depth, right? And then we will find the LCA, right? So let's understand from where we will start, right? So let's think if we have a function that will iterate over our you can say tree, that is called DFS. I will go with the till the depth of the root node, right? So I'll start with the root node, and as we know, the depth, initial depth of the tree is nothing but 0, d, right? I said, right, d plus 1, d plus 2, like that we have to go, right? So initially will happen, DFS will keep iterating all the nodes, and that is nothing but DFS, right? And so it will keep going to the depth from the parent to its leaf nodes, right? Next we'll return LCA. And what is LCA? The leaf, the list common ancestor, right? And so I will define LCA, right? What we will do, we'll create a private int max depth, like this. Okay, and we'll say nothing but 0. Okay, so this will become your max depth, right? It will keep increasing one by one, right? So you will find the max depth. If you want to return it, you can return it, or you can leave it also. Okay, but we want to keep track of the max depth, right? From where we can find it, right? And then we will have the LCA. So we'll create private, this is become also the tree node, right? And then we'll say LCA, and we'll start from initializing it null, right? So we have defined LCA and max depth. Now we have to create that only left part is DFS, right? Let's create the method. So I'll write private. You can write anything, you can return int and those, right? I'll write int, or you can also write a void, and you can improve it, right? I will write DFS like this, and so like this. Okay, so root node is nothing but, what is your root node? Root node is nothing but our tree node, right? So I'll say this is nothing but node, and the depth is what? 0, right? Initially. So this is nothing but your int depth, not the max depth, it's a depth, right? We'll find the max depth later, right? Now you can see the function is ready, but a skeleton is ready, but we have to implement the DFS, right? So it will iterate. So first of all, if the root is not null, so here root is nothing but node. If node is not null, then we'll increase. If it is null, right, then we'll return the depth, that this is the depth we have to do. Now if the root node or node is not null, then what we will do, we will find the max depth. How will find the max depth? Using the formula math dot max, and the max depth is initially what we have 0, and the depth is also 0, right? But further you will get the depth, and so you will increase the max depth, right? Now we have to find, let's suppose the tree having two children, right, left and right, because it is binary tree, right? So you will go left depth and the right depth, right? So I'll go with the let's suppose first I will go left depth. I'll say left depth is nothing but, we'll call this dfs function, sorry, dfs, right? And then we will try two things. The first node that we have, so now we will go to node left, right? And then the depth will become what, will increase +1, next level, right? As we know, we'll start from the up 0 1 2 3 like that we will go. So we'll keep adding +1 in the depth, right? Similarly we'll do for the right depth, we'll find similarly dfs, and this is the method. We'll say node dot right this time, and then depth will become, if this is depth, it will become depth +1, right? Now what is left, we have to make a condition, right? If, what is the condition? If left depth is equal to max depth, let's suppose, and right depth equal to what, max depth, right? If this is the case, what we should do, we should do LC is the node. In that case, you remember, like 4 and 5 was coming, right? So if the current node is LCA of the deepest leaves, right, we have to return it. So LC will become node. Got my point? Otherwise we have to keep finding the max depth, right? So let's suppose return max. We'll find the max, we'll find math dot max a and b. So here a will become left one, left depth, why it is not, sorry, keep it, just copy it, and right depth, okay, like this. You understand, right? So first we'll go to the left depth, then the right depth, right? And we'll find it, okay? So give me 1 second. What I can do, I can teach you first, make you understand, okay? Okay, give me 1 second, okay? So let's suppose what I'm trying to say. If you remember, we have created a tree 1 2 3 4, right? So LCA, the lowest common was LCA is 4, right? This one, that time, right? Because this one, if there is one more node behind this, right, let's suppose here is 5, right? So there is 2, LCA will become, right, 4 and 5, not LCA, the lowest common ancestor to become the node. There is 2 leaf node having the most you can say depth, right? And so 4 and 5 is the lowest one, right? So the LCA will become 1 because this is in this node, right? Similarly, if you remember the previous one, right, there is so many was there, and then in there 2 and 3 was there, right? So there is 2 and 3, let's suppose. If any node is there, right, let's suppose this is node, right, and any node having the lowest leaves, right, this will become, we have to return this one. So this will become the LCA. So let's suppose we have the max depth we have, right? So this is the it will keep improving, right? It will keep improving. So this will become your left depth, and this is your right depth, okay? So if left depth and right depth is equal, right, so we have to return the node, parent node. Let's suppose if any other thing is there, so many parents are there, right? So many parents are there, and if this is the left, let's suppose this is contain this one, right? So in this case, what we have to return, this part we have to return, right? Because 4 have connected with this node. Let's suppose this is 7, and 7 having 8 and 9, right? So now 8 and 9 having the lowest ancestor, right? Lowest you can say leaves, and the left will become this, and this become equal. Left and right depth will become equal, right? And so the LCL will become this one, right? 7. And so that is why we are writing here the left depth and right depth is equal, and so we will do that. Otherwise we'll keep finding the max depth and right depth, right? And we will store it, right? So you understand, right? The DFS root DFS root, then we'll start with the 0. We'll start from here, and then we'll keep tracking of all the nodes until we find the max depth of left depth and right depth, right? And then we will return it. Okay, so now you can understand, right? What is the use of max depth? So max depth keep track of this max depth will keep track of the deepest level in the tree, right? And what is the use of DFS, right? So DFS computes the depth of each node and it will update the max depth, right? This is the use, right? So what we have to do, we have to correct LCA handling, right? If both left and right subtree reach the max depth, right? So the current node is the lowest common ancestor, right? So a proper depth we have to return. So the DFS function will return the maximum depth that is found in the subtree rooted in the, you can say, node, right? And so we will return it. Okay, if we talk about the time complexity, so it is going with all the nodes, right? So time complexity will become O of n, right? This is the optimized one. We cannot say how can we optimize it, right? So if we say time complexity of n, because we are iterating all the nodes, right, where n will become the number of nodes, so we have to iterate all, since we are visiting each node once at a time, right? So this is the implementation code that we have here, and let me submit that. I have not submitted it. Okay, let me check what is the problem. So this is the function we have given, and it is saying we'll get 108, right? And the expected is 274. Okay, so let me check. So let's understand what we have issue here in the code. So I think we have taken this max depth is fine, this one. Okay. The problem is that so the max depth is updated during the DFS traversal, right? So this can lead to incorrect LCA selection, because max depth might not be fully computed, right? So when we are checking left depth and right depth, right here, so that is not happening here. So LCA might be updated incorrectly, right? So if the subtree is deeper than the other, right, so we'll check the max depth and the right depth, right? Left depth is equal to max depth and this, right? So it fails. So when the LCA is setting, it is incorrect, you can say, right? So even when the LCA correct LCA should be set, right? Like that we have to think, right? So let's suppose what we have to do. So max depth, what I will do, I will, because it is returning the max, it returning the integer, DFS is returning integer. So I will put what, find the max depth of the subtree, right? And you will keep it here, right? Now what we will do here, okay, this is the function. We'll say LCA, looks good to me, right? But there is one problem is here. I think we should create one more function. So yeah, let's go with another function that we can find the max depth, right? So I can remove for here. Let's suppose we'll call it give a correct name, DFS, and I'll say nothing but find, give the name find max depth. Okay guys, so we'll say find the max depth. Okay, and we'll say is root, right? One more level we should go, and then what we can say, so first we'll find the max depth of the tree. What I'm trying to do, right? So the first step I'm trying to do the find the max depth of the tree. So we'll find the max depth and we'll keep it here. Okay, now so let's create it also. So let's suppose we'll have nothing but it become private int and we'll say find max depth, right? And this is nothing but our tree node and this is node. Okay, so this node is nothing but our root node, right? Or our node will keep changing also. Okay, so if node is equal to null, so in this case what we should return, we will return 0. Okay, then what we should return, right? So let's suppose if it is not if it is not null, right, then what we will return, we will return 1 plus math dot max, right? And then we'll pass two argument in which we will find its sub children, right, left side and right side. And this is the problem is happening here, right? So we'll find max depth and 2 times for the left and the right. So node, we have node here in the root is not there, we have a node dot left and we'll pass here node dot right, right? We'll pass node dot right like this. Okay, then we'll compute it and we'll return it. Okay, so now the next thing is what we have to find the DFS, right? So DF will keep here LCA. LC is nothing but DFS that we have already. Let's keep it here. We have to iterate, right? We should iterate it. So that we have already done, right? But give them name as a. This will become root, right? I have removed that root, and this should be depth is nothing but we should put 0. Okay. Okay, I think it should work. The root is here, DFS method is already implemented, root DFS. Okay, fine, let's try it. No, let me check the DFS method also. So if node is null, we will return the depth. Max depth we have max depth and depth, we'll find the max depth. Left depth we have DFS node left and right, we have the depth, right? Okay, and then we'll find, let's keep going down, then we'll have the calculation that will update the LCA, right? So if this is equal, we'll say node, right? Otherwise we'll return. Hope this will work. Let me submit it. Accepted. Congratulations guys, and let me submit it. Perfect. So this is the month 4, right? And this is this is the day 4 of March, and we have completed this challenge, right? And so I hope you understand the problem. So the time complexity will remain same that we have already discussed, and only part we have missed it, that we updating the max depth, right? And finding the max depth. So either we will go the left side and the right side, because we are doing DFS, so we should go with left and right finding each other, and then we should do 1 plus at a time, right? So I hope you like this guys, and if you have any doubt, please ping me in the comment box and I'll be helping you there. And if you have any suggestions, any thing, please ping me in the comment box. So this is the optimized version itself, and no need to worry of, right? So the what we have done here, right? So first we have find the max depth, right? First we have find the max depth. Let me summarize, we should summarize, right? So first what we have done, first we have find the max depth, right? And then we have traversed the again to locate to RCA, right? Not RCA, it's LCA, right? Lowest common ancestor. And then we have update LCA when both left and right subtree reach max depth, right? So the time complexity will remain same, right? O of n to find the max depth in a single pass, and also to find the LCA, right? To find the LCA in other pass, you can say is O of n, right? So the total time complexity will become O of n, right? And yeah, so that is the thing that we have seen, right? So if you'll talk about what is the final takeaway, right? So we have pre-compute max depth first, and we have only updated LCA when subtree reached to max depth, and then we have separated the function for the clarity. Okay, thank you for watching this video, and let me know if you have any doubts in the comment.
Thank you guys, thank you for watching this video, and if you really like this video, please subscribe this channel.